say weedy or weedy? Weedy. Like Wheaties?
Weed as in Michael?
Oh yeah, yeah, it is.
Hello.
Kind of creepy, but anyway. Alrighty, so let's see. Define a function used in powered series. Got a bunch. Word, convergent, word, convergent. Yes, domain of convergent. Alright. So I'm gonna go to here. Okay, so now we're gonna define this then. Analyze a function defined by power series. Alright, so now let's first look at this thing. What is this one gonna be though? Is that a geometric series here? Just x to the k, and I'm trying to define it by some values of x, right? So think about this carefully. When is this right here going to be convergent? Think of the numbers.
If x is less than 1.
Very good. If x is less than 1. If x is less than 1, then this thing is going to converge, right? So I could state, because the domain of this for this to be convergent is going to be less than 1. So I could say that. So my domain is going to be from -1 to 1. Now this is actually a geometric power series, geometric series where we have like an R value, an A value, and to the K, right? You guys remember that? It comes out something like this, where we have A. What? All right, that was weird. Okay. All right, so we have like an A to the R. That is not liking me today. Come on, you can do it, board. Come on. No. Nope, not again. All right. Come on. Ah! Living in a lonely world. Took the midnight train going anywhere. Ah! Oh, I almost had it. Almost had it. Almost had it. Come on, come on, come on.
Almost there.
Ah! Yeah! Anyway, all right. Anyway, okay, maybe that'll help it. Okay, anyway, do you guys remember this thing? Where we actually had something like this, where the geometric series, and we were trying to figure out where it's going to converge to. It was, if you have 8.7 notes out, 8.7 notes, it's actually in there. So you guys want to have these things. Yeah!
Viewers are like, why does this teacher make so much noise?
Man, okay, I am not saying any cuss words right now. There's some colorful 4-letter words I want to be saying at the stupid board, but I'm just gonna say thank you. I have a smart board that it's special.
Wait, you said viewers plural?
What?
Viewers plural, as in just that one person in Nova Scotia, Canada, that actually watched my video the other day. So, thank you, Nova Scotian, even if it was an accident.
Is it not plural?
I don't know.
I know, like I get 1 views. All right.
Confused.
Okay, so when I'm doing this, I come up with something that looks like this. It should be.
It is not gonna.
That's a pretty straight line. I'm really impressed.
You know what? I'm just going with it.
Then we can just easily do like one.
Satanic scripture.
Yeah.
The power of Christ compels you.
That's like
The power of Christ compels you. I need an old priest and a young priest. There's gonna be like some head turning and some like split pea soup going everywhere on this thing.
We gotta get Rocco in here.
I know, we need exorcism.
Rocco said he was.
Yeah! Okay, anyway, when I'm doing this right here, you guys have this in your notes. The notes that I asked you guys to take out, right? So it is there. So it's an A value over 1 minus R to figure out my convergence for this, right? Say yes. Okay, thank you. So from my previous thing, I know that my radius of convergence is going to be from -1 to 1. So my domain is actually from -1 to 1. So we got that part out of the way, right? Say yes. Okay, so find the domain of f. So now we're going to do the domain of this. So this is my geometric series right here. So I'm going to plug this into that. So that's an A. So in this case right here, my A value is going to be, say 1. 1, right? Say 1. Very good. So my A value is going to be 1 in this case. But now, we're evaluating f of 1/2. So what am I doing with that 1/2? It's going to go into where? F of 1/2. It's going to go. It's going to go for my x. Thank you. So it's going to go in there. So now it's going to be, for this one, it's going to be 1 over 1 minus 1/2. Just go with it. Seriously, just go with it. All right, multiply everything by 2. Top and bottom by 2. So it's going to give me 2 over 2 minus 1, which is going to give me 2. Living in a lonely world.
Oh, is that why like the fraction thing flips?
Okay, so we evaluated for this. So now, in this case right here, we evaluate it. It comes out to be 2. In this case, yes, we evaluated for this. It's this. So it is going to converge because it's converging for anything that was less than 1, right? Yeah. Anything less than 1. So we plug in a less than 1 here. So it's converging to 2. Yes? Yeah. Okay, good. All right, let's try another one. So that -1/3, I'm going to do the same thing. Is that inside my radius of convergence? Say yes. Okay, good. So 1 over 1 plus 1/3. Yeah!
I can tell us something here.
I know, right?
Help me.
Okay, so let's go ahead and multiply everything by 3. So it's going to give me 3 over, let's see, 3. And that's going to be plus 1, which comes out to be, I know, it's going to make a pentagram here in a second. All right, so it's going to be 3 over 4. So this one's going to converge to what? 3/4.
Trying to keep her sanity.
I know, right? All right, so now for this next one, find f by summing the series. Okay, so now we don't really have anything for this except for what we're gonna get. So we're gonna come out with the geometric series, and we know for it to converge, I know that's this, the domain of it, so x has to be less than 1, right? So it's gonna be in between -1 and 1. So it's gonna look like this. So it's gonna be 1 over 1 minus x.
It's drawing another triangle.
For the geometric series, we're summing it, and so we're just plugging in value of x, okay, for any value, right there, right?
Yeah.
Where the domain would be between -1 and 1. So I can figure out what the sum of all this, of any series, anything in this, within my domain of convergence. Make sense? Yes? Okay, good. Okay. Represent each of the following functions by power series centered at 0. Okay, so I'm gonna treat it just like the geometric series we just did a second ago. Okay, so if I'm using the same information, the same type of problem, right? So I would rewrite this as what? The sum to x squared to the k. No, too well.
So 2x squared to the
Yes.
it's kind of
Okay.
I think your board is sick this time.
All right.
Why do they keep doing that?
It's possessed.
It's remembering a point like you press 30 seconds.
I know.
And you're like drawing, and it's like, oh, you're over here.
All right. So anyway, are we okay? So summing that out. So if k is 0, what would my initial be? Well, yeah, so I could basically, actually I don't really need to rewrite it anymore because I could still leave it k equals 0, but if I change it to k equals 1, so my first term would be a sub 0, which would be 1 plus all the terms left in that, so I could get my, no, I'm good. All right. So what about this next one? Is it in the form that I need? Say no. No, it's not in the form that I need. All right, let's see if I could actually change something here. I'm going to turn this off.
What was the purpose of changing that into that sum?
It's asking for it. Represent each of these following by power series centered at 0.
But how can you only put like part of it, part of the actual equation?
What do you mean part of the actual equation?
Because you're doing a, right?
Yeah.
And it was only 2x squared. There's still left.
Oh, I got stuff. Yeah. Okay, it was 2x squared what?
2x squared to the a, like that was only. Like part of the function. Never mind, just continue.
No, that's the geometric. Because if we go back to a previous one, the previous one is this right here. Here's my geometric. That's the geometric one right there, right? And so in that case, I actually Okay, so I'm just going through and actually trying to fit it into where it would be. So in this case right here, my x value is just this. This is like the most basic. It's 1 minus. It's already in the form that I need. But on part B right here, is it 1 minus yet? Say no. No, it's not 1 minus, is it? So what could I do here? I could divide out a 3, can I? Take out a 3. So it's going to be, and then it's going to be 1 over 1 plus x over 3, right? Actually, let's make it a negative. If we make this one negative, I could change this to be a negative. There we go. All right.
Draw a line of the eraser.
It'll still be a negative.
Okay, so yeah, so now I'm going to have a negative 1/3 in front of my sum as k equals 0 to infinity of, I'm going to have my r value is x over 3 to the k.
Like when I meant like if you take out a 3, like a negative 1/3 from a 3.
It's in front of my sum, so yes, that's going to go as part of my a value here. That's the a value in this one. Does that make sense or no? Because I pulled it out front first, and that's this, and then my negative 1/3 is the a for the piece that I need. From the geometric series, remember that there was an a times the r to the k.
I know, but
So it's negative 1/3 over negative 1/3. So it's 1. That was 1, right? There's 1 on the numerator and 1 on the denominator.
So I just factored a 1 out of, I factored a 1 from the top, I factored a 3 from the bottom. I don't know if you can kind of see that, but yeah. All right, I'm gonna